So hi everybody. In today's video, we will be quickly actually leveraging this context of PowerProtect Data Manager for Kubernetes. And like we said that to protect the Kubernetes clusters, in this case specifically the EKS Anywhere clusters and the workloads running on it, we have to start by installing the PowerProtect Data Manager and the surrounding contextual elements that will actually host our backup data, right? Like the data domain and whatnot. So I'm joined by Raghava. Hi, Raghava.
Hi.
Hi. Raghava is my colleague, and he's the expert on PowerProtect. So I'll hand it over to him, and he will be starting and guiding us through how to install PowerProtect Data Manager and the required contextual elements. Over to you, Raghav.
Sure. Thanks, Amba. I'm going to share my screen where we will be installing and deploying PPDM. So PPDM comes with a virtual appliance. It's an OVA file where you can actually deploy it, and basically it's 1, 2, 3 steps, and you provide all your IP details. It will be deployed. Once the OVA is deployed, basically a VM appliance, it will come up with all the services. All you have to do is just log in and configure. Let's start by deploying a PPDM. So we're going to deploy 19.2 with 19.12, which is the latest PPDM version.
So Raghava, while you are deploying this, let me also ask you, while we are deploying this in a vSphere environment, can I deploy PPDM? Where else I can deploy PPDM?
Yeah, so you can deploy PPDM in VMware infrastructure as a OVA, and then you can also deploy in public cloud, AWS, Azure, as well as GCP.
Okay, and these come as standard machine images in the respective clouds?
Yes, respective clouds will have the images in their marketplace. You can just go and grab a marketplace from the marketplace.
Okay. So here we are using the OVA method for vSphere environments.
Exactly.
Okay.
Yeah, I'm going to fill in a little more details here. All right, we are going to select the data center, which is IAC. And I'm going to provide all the resources. Basically, it requires about 650 GB of capacity storage and about 10 cores and maximum of 32 gig, but you can manage with 24 gig. And it can support 10,000 VMs backup. So one PPDM can scale up to 10,000 virtual machines backing it.
And just for the for the viewers, here are use cases virtual machines. But those virtual machines are the Kubernetes cluster nodes, right? For our EKS Anywhere cluster. But Raghava's opinion will matter a lot in terms of how ubiquitous PPDM is in terms of a broad array of protection scope in terms of virtual machines and whatnot, right?
Exactly. So we can protect virtual machines, we can protect containers, like you said, EKS and OCP, all the other platforms. And we also protect NAS systems. We also can protect physical systems, databases, and it's like an all-in-one enterprise product for that. So I'm going to select VMware on premises. As you can see, I think you asked a question. We can have it on GCP, Azure, and of course, AWS as well. All right, I'm going to select data store. I'll leave it as default. And here comes the network. If I'm not wrong, it's ISC PG. All right, I'm going to provide IP address. And these are the IP address here, the default in the lab, and the gateway we already provided. Mask, it's all good. I'm going to give the FQDN name as well. So all the details are filled. Basically, whatever required for this appliance to run, typically IP, gateway, netmask, and DNS. That's all it needs, so that when the service is deployed, it can come up smoothly. This is a summary of it, and you're going to hit on finish. Right. So it started deploying now.
So what you just showed is, I mean, looks very easy, right? I mean, it's
very easy.
The impact of this simple installation will be very high, but the process itself is very easy, right?
Very easy.
Okay. How about licensing for this? Does it come with some trial license, free license? What is it?
Yeah. So PPDM by default, when you install and deploy, it comes with 90-day free version, which means until 90 days you can absolutely evaluate all the features that it can offer, and post 90 days you can upgrade to a permanent license. License comes with two different methods. If you are backing up virtual machines and like containers, you can go for the socket-based licenses, how many sockets you have on the vCenter, and are backing up a huge amount of data and you wanted to go by capacity, is also possible, which means if your front-end capacity is about 100 terabytes, you can license it for 100 terabytes and you can back up how many number of systems you want. These are the two types of licenses available.
And I've also heard that, you can actually do away with this predictability question in terms of how much capacity do you need by leveraging some of the as a service model from Dell, right?
Absolutely. I totally agree with you on that. All right, so it's in progress. Let me see where it is. All right, looks like PPDM now is installed, and I just powered on. And after we power on, it takes some time to bring up all the services. And let's check if PPDM is installed. This is the DNS name we registered with. And get it. And first time installation, it shows as a fresh. This is one-time setup. After we bring up the PPDM appliance, if you have taken a backup in the past and you have reinstalled it, you can actually restore it. Otherwise, it's a new install. In our case, it's a new install. And end user agreement, like I mentioned, we don't need license for the first 90 days. You can here either if you have a license, you can upload it, or 90-day evaluation license, which means all the features will be available for 90 days. And you can actually set your administration password, use the same for everything. I'm just setting up password. All right, this is the admin password, and after that, select the time zone, which is Australia, Sydney. NSW. All right, NPP, if you have anything, you can enter that. You can configure the mail setup. For now, I'll skip it. And this is all we require to make the PPDM up and running. Now it just sets up the first time configuration and settings. Once we are done, the system is fully up and running. From then onwards, all we have to do is configure the target devices where all these backups can be stored. So PPDM, which is PowerProtect Data Manager, integrates with data domain system, whether it is a physical or virtual. It's the same procedure. As long as you have the credentials for DB and data domain, we can integrate with it.
So maybe it's helpful, Raghav, if you can just highlight the fact as to, in my understanding, right? I mean, PowerProtect is really an orchestrator of sorts, right? For creating these backups, but the actual storage of these backups happen on a different entity, which is the storage device or the appliance, in a physical form or in a virtual form factor, right?
Exactly. So you have
data domain is, right?
That's what data domain is. Data domain physical system is the biggest system, the largest system we have is about 1.5 petabytes usable capacity. And if you think about 20x deduplication, basically you have about 30 petabytes.
That's huge, right? I mean, 30 petabytes is, and does it also reckon with the virtual appliance model, that same capacity, or it's different?
No, virtual appliance, obviously, it is limited by the physical hardware. We have various configurations like 32 terabytes and 64 terabytes and 96 terabytes. Okay. In the on-premises world, and we also have in public cloud.
And just for the viewers, basically, PowerProtect Data Manager itself can be deployed as an OVA or as an AMI or a machine image in public cloud, like how we discussed. And likewise, the data domain, the counterpart of PPDM for storage, can also be deployed on-premise as an appliance or as an OVA or in public cloud as a machine image, right?
Exactly. So truly multi-cloud and hybrid cloud world where you have similar kind of products available for you on-premises or in public cloud. And at the same time, you will be able to manage all your PowerProtect data managers through a single console. What we call it is the data protection central. So you can add multiple PowerProtect data managers to it and then launch all those different systems. Data protection console is not just for PPDM, but also for all the other products like Avamar, Networker, and all the other data domain systems like a centralized place and a view.
So basically, you can orchestrate your backup scenarios and restore scenarios in any of the clouds of choice, and whether they are built as private clouds on-prem or in the public cloud.
Exactly.
Okay.
And truly multi-cloud.
Good. Now, I think that gives that amount of confidence that the use cases can be very broad, both in terms of the placement of the workloads and also in terms of the complexity or the diversity of the workloads, like virtual machines, containers, application databases natively running, and things like that, right?
Exactly. One is the different kinds of workloads and different products you support. And the second thing is wherever your data is, whether you have a hosting location in some other data centers or closer to public cloud, colo locations or on-premises, public cloud everywhere, right? You have the same product and we'll be able to manage it.
Great. So while this setup happens, why don't we actually spend some time on navigating what is there in terms of the cluster and what have we actually loaded on the cluster? Shall we do that?
Yep.
Okay.
Sure.
Okay. So let's look at what we have, Raghav. Basically, we are working with a scenario where we have the Kubernetes cluster, right? And specific use cases around EKS anywhere in this case. And like we have initially described while setting the context, is that sockshop as an application framework, right? Which has about 8 microservices and about 6 data services, including MySQL, MongoDB, Redis and whatnot, right? And all these are basically built through a persistence layer of CSI over Power Store array of Dell Technologies, right? And that's where we are bringing PPDM into the mix. So let's just observe the cluster first. So if I just say no,
Yep.
you can see that there is an EKS-A cluster running. You can see the distribution of EKS. It's the same distro that runs in public cloud. So it's the Kubernetes version is 1.22, and you can see the label of EKS. That's what you will see in public cloud too, depending upon the version variants. But we have 2 master nodes, and the MD nodes are the worker nodes, basically. The etcd nodes are basically a disaggregated form. Basically, you have a separate set of etcd cluster, 3 nodes running. So let's not worry about it right now. Now I have a namespace here, which is called as sockshop. And in that namespace, basically, you can see that there are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pods running. Some are stateless, some are stateful, and I'll describe that. But practically, this is not a small, application. This is a widespread deployment in terms of the diversity or a polyglot architecture, right? You have basically cards and different functional logic of the application and the stateless applications. And then you have the databases, which are like suffixed with DB, right? Orders DB, RabbitMQ, and all that, which are basically persistent services. Now, if I look at the persistent volumes, which are a result of this application in this namespace, you can see there are about 6 persistent volumes, right? I mean, this is what it is. And you can see the storage class used is Power Store. And very quickly, if we grasp, if I log in into my Power Store, and I will be able to see those particular volumes also. Okay, so let's just go to storage volumes, and I'm going to just filter out. You can see here already, but there's a nice filter I can apply through the prefix. You can see that there are multiple volumes. Some were created previously, but right now what we have is basically C4 EKS-A1. You can see all these volumes here. Now, we have the volumes, we have the cluster, we have the application, which is running here. Sockshop. It's a complex maze, and in this we will simulate the eventual crash, right, in different cadences. Now, point is, before we start, I think
one question.
Yeah.
Sorry to interrupt, Amber. One question. So, what kind of databases are you running with this?
Oh, okay. Good question to highlight. So if I just go to, for example, if I go to my blog here, you can see that the entire Saga series captures this particular use cases and things like that. And we have a sockshop as a use case here, right? And you can look at this use case. So the entire detailing is done here. You can see 6 data services. So Mongo, MySQL, Mongo, Redis, and RabbitMQ. What we are missing here is an equivalent like a Postgres or a Cassandra, right? But that's okay. Point is, we have a good diversity in terms of the data services being used here. Plus, on top of that, you have secrets also stored, like SSL certificate and things like that, which also will get backed up, I presume, as a part of the backup and restore process. Now,
one thing to highlight, on the database front, you have MySQL and you have Mongo. So we have PowerProtect can support a consistent backup of these databases. So how does it work? We will have the script executed pre and post. We call it the pre-hook and post-hook, which will keep the database in a backup mode, takes a persistent backup of PVC, and also even flush the logs to PVC and then backup. So it gives you a consistent backup capability as well, PowerProtect manager.
Got it. And that's, you're saying basically instead of the PVC being backed up, you're backing up the actual database itself at an application layer, let's say that, right?
Consistent database, flushing everything to PVC and then backup PVC.
Got it. Oh, okay. Got it. And that's an embedded workflow. I don't have to do anything on top of it.
Yes, the user doesn't have to do anything. It's a seamless flow and integrated. It's one-time configuration.
Got it. So I think now we will emulate the roles here. So I'm naturally onto the cluster, and Raghava, you are managing the PowerProtect there. So I'm going to run the set of commands mainly to give you the access to the cluster through the service account model, right? So I'm just going to copy paste these commands. The first command will actually create a cluster admin service account. And then the second command will ensure that the cluster admin permissions are granted on the cluster for that service account. And lastly, in order to create backups and to restore, we need the ability to have snapshot classes, which will allow these temporary snapshots to be created in the cluster before they are backed up onto the data domain, right? Create the snapshot, move the snapshots, and then delete the snapshots, right? But in order to do so, we need this snapshot class. Again, in this case, the temporary storage for these snapshots is going to be PowerStore. So the CSI drivers being used in the snapshot class are also PowerStore. So let's do this. So all three have been created. So Raghava, I'll give you the access in terms of so it's a nice set of couple of commands there. I'll just retrieve the service token for the service account that we have created, and I'll just pass this over to Raghava so that he can initiate the discovery process, right? Let's just share this. I hope it works. Zoom sharing.
Yeah.
Okay, let's see.
Okay, let's look at if the system is up and running after the last step. Thanks for showing that, Ambar. That was very insightful about the cluster and the details. So let's look at PPDM. So this is the first step. You could configure various parts of it, and let's start configuring storage, which we talked about it. Basically adding a data domain or integrating data domain to the system. So you can select PowerProtect data DD system, and the host name is DPS DDV1 IAC, and the IP address I need to check. '73. All right, the port you can see default. We need to add credentials, so we need to create a name. All right. Well, let's see if the system can accept. It's accepted, verified, which means we have provided data domain virtual edition details here with credentials. What it does now is go ahead and configure the data domain virtual machine as a storage to PowerProtect Data Manager. As you can see, it's completed, and the rest of the things we will configure later on. As we told you, it's a trial license, 90 days. I'll just remove this warning. All right. There are a couple of options you can see. Infrastructure, where you can configure the infrastructure for the backup environment, and then protection is where you define the policies. Restore is where you want to perform the restores. Alerts and administration is about managing role-based is access control, and then reports and jobs. We have added the storage. Now you can see that the storage is added, last discovered, and status is ready. So which means we are ready to go. Now we have to discover the PPDM server that Ambar actually showed us. For that, we need to enable the asset sources. Basically, enabling is nothing but, we will enable Kubernetes type assets to be discovered by this PPDM because this is new. It's enabled. Once we add the cluster, we will see all the namespaces inside assets. So right now what we're going to do is provide the cluster name. We will say EKS anywhere. The IP address, Sambar.
Yeah. So it's 172.
Right.
24. 165.11. 11. Let me just confirm if it's 11.
Yep.
I think it's 11. I'll just make sure that we don't falter on that, right?
Yeah.
Okay. Yeah, it's 11.
Perfect. And
port remains same. Yeah.
Port remains same. Host credentials. If you can paste the service account, it'll be great. Token.
Let me retrieve the service account once again, and then give it to you. Okay, so yeah.
All right, so we added the credentials to it, and let's see if it can verify and validate. So you can see successfully verified, which means EKS Anywhere has accepted the credentials. And all right, so we saw that it was successfully saved, and now you can see that the cluster has been added to the system. Let's try and discover. So what this discovery does is it goes and finds out all the assets, which are basically namespaces under this cluster, and adds all of them into the assets. Now you can see the discovery status is okay, which is successful. And when we come here, you can see all these namespaces which are part of this EKS Anywhere cluster, about 20 of them.
Yeah, and I think
anything to add, Amba?
Yeah, the emphasis is on the sockshop namespace. So if we click on that, and we slide to the right, we will see that there are about 6 PVCs that we spoke of. Right now, the status of all the assets is unprotected. And what we are going to do, what Raghav is going to do, is basically protect this particular namespace itself, which will include the pods, the TLS secrets, and most importantly, the data, which is these 6 PVCs. But before doing that, what we will do is, we will punch in some of the application workflows in terms of creating a demo user and a sample order, let's say that, right? So Raghav, if I can share my screen, I'll go to the application and quickly do a workflow insertion so that we can take advantage of having the application, and then also being able to validate what's going on in the application context, right?
Absolutely.
Okay, so I'm going to go to sockshop.thecloudgarage.com. Again, this is protected through a self-signed certificate. One of the important things that you need to note is, I just accepted a self-signed certificate. When the restore happens, actually, I will not have to re-accept this particular privacy warning, because the restore also will restore the TLS secret of the certificate. That's a good validation use case, actually, in terms of what all it can restore, right? Not only the PVCs, but also some of the secrets and other CRDs that you typically work with in a Kubernetes construct, right? Let me register. And in terms of the registration, let me just put in Amber Hassani. And let's say, I'll put in some Amber@cloudgarage.com, a password that I can recall. Generally, these kind of testing scenarios, I will forget the password. So some simple password. You can see as we did this, the user DB and the user, microservice has basically been invoked here. So the workflow has been kind of instated, from a user DB standpoint. Now, when we click on catalog, what you are invoking is the backend catalog DB and the catalog service actually. Let's add something to the cart here. Let's say this. And at that point of time, you are basically invoking the carts DB. And we already have one item in our cart. And we can then go, I need a shipping address here. So let me just put in some dummy address, ABC. City is also ABC. Let's say, 11111. And let's say NZ. I mean, I'm just kind of putting in something. So there's a shipping DB also, and which is also working hand in glove with the the user DB. And now the payments 1111. Okay, let's put in some dummy data here just to invoke some of the persistent nature of the application. Okay. So what we do now is basically proceed to checkout, and as soon as we do a checkout here, basically you can see that you will have an order ID, right? So the ordering microservices also has been worked upon. The orders DB is also populated with a single order, and we can view the whole order detail. This is the order. What we intend to do, Raghava, is we will crash this entire namespace, which means that if we don't back up our data, we are going to lose the demo user, we're going to lose the order, and everything else which is actually ephemeral in nature unless persisted during a backup and restore, right? So let's, the data is already there now. I'm going to do a quick log out, and Raghava, I'm going to stop sharing so that you can move and then capture the current state of the application and the context with which it's operating.
Yeah, I'm back. So yes, now we have seen sockshop and the application and the persistent nature of it and microservices working together to make up that app, and that includes all the different components and databases, and the PVCs that we just talked about, like 6 different PVCs, and how we protect. So all of them are inside the namespace called sockshop, and let's look at how we protect this particular namespace. Like we mentioned earlier, we need to create a policy or define a policy to add all this. So let me create this policy as test EKS, and policy type is Kubernetes. Let me walk through quickly. Crash consistent or exclusion. Let's go for crash consistent. And you can see that all the namespaces are visible here, and we can select sockshop to protect, and we will also get an option to exclude some of the PVCs if any user wants to exclude them. But in this case, I'm not going to exclude any of them. All are included, right? If I toggle this, it will be excluded. So all these are included. So sockshop namespace is included as part of this. Next, and we define where this backup has to be stored. And let's add the storage unit on the data domain that we just created. And schedule, let's back up this every 12 hours and retain this data for 7 days, for example. Right. We have a lot more details like retention lock, which is basically immutable copy of the data if you want to, so that it can protect from any unwanted encryption and ransomware attack as well. So SLA is, you can define an SLA and then it will highlight if there is SLA miss. For the simplicity, let's proceed. And we have defined what the target is and what the schedule is, and you can actually replicate this backup to another data domain in a different site for a disaster recovery purpose, and any recovery purposes. Cloud tier is for the long-term retention data. All right, so we have defined the policy, inside the policy, the storage as well. This is the last step, where one asset is included, and the asset type is Kubernetes and sockshop, including 6 PVCs, backup schedule, and the target. I'll click on finish. It'll take a moment to create a policy, and then we will be ready to go. All right, we created a policy. As you can see, it has all the assets in it. Let's start the backup right now, which is protect now manually all the assets. And I would say you can customize any retentions you want. Otherwise, just go for the default. All right, we triggered the backup job and waited for some time. And now the backup job status shows successful. And let's get into the details of it. As you can see, it transferred about 13 MB and one asset protected, which is sockshop namespace, and total size is about 1.2 gig. You can see the asset name and has the deduplication and etc. And if you want to really check what exactly backed up inside, we can see the step log where initially it starts backing up all the metadata, and then preparing for the backup. And you can see the metadata. Metadata is all about Amba talked about all the secrets and services, all the configuration, anything and everything except PVCs is backed up as part of the metadata. And then it started taking the snapshot of the PVCs using the CSI, and then we started backing up each one of them, one at each. So when we try to back up this PVC, there is a container proxy that spins up on the Kubernetes, and each container proxy is responsible for backing up one PVC and then transfers the data with a source deduplication to data domain. Like you can see, there are so many PVCs and they all have been backed up. Once the data is moved, the snapshots have been deleted and the backup is successful. More details here, the size and how much is the data reduction and how many volumes it actually backed up. You can see the backup level is full and 6 volumes backed up. All of them are successful. This is how we perform the backup.
What you're saying is basically, although the defined size of the PVC is roughly about 8 into 6, which is 48 gigs. That's the size of the PVC, but the actual data which is on those 6 PVCs is roughly about 1.2 gig here. And we can see, it basically, just optimizes the whole storage system, right? In terms of it's the actual data that is backed up. And we see the restore also, the definitions of the PVC will be recreated, and then the actual data will be kind of, populated.
Yes, source deduped and then transferred to the data domain.
Okay, so I think we will hop on to the next natural, state as we progress of.
Which is your favorite of disturbing existing setup so that you can demonstrate the complete restore of sockshop whole namespace.
I get inspired, right? I mean, once this is there as backup, I can go ahead and simply detail out in terms of the, the disaster. I can create multiple simulations, but deleting the entire namespace is an eventuality of sorts, right? It could simulate a database corruption of one PVC versus the entire application being corrupted and things like that, right? And based on our backup schedules and the RPO, RTO requirements, we can institute a nice protection policy that can instill that level of confidence that if entire cluster or the namespace also goes down, I have the ability to recover my, state of the application, and that's what we will see
in the next step. Yeah, absolutely.
The protection policy has created the backup successfully. And in that, if we all recall, if I just go back to, the application, I had one order ID and a demo user created basically, right? For the sockshop application. Now, what we're going to do is something interesting, right? And it's a disaster of sorts. Mind you, when disasters happen, you really can't predict what went wrong. And it's very difficult to kind of restore from, those kind of eventualities. Now, let's quickly look at what we have in play right now. We have the pods. Okay. We can see the sockshop pods are running. We do have the services for sockshop. Okay, that's the namespace. We do have the persistent volumes. Right, the 6 persistent volumes for the different persistent services, the databases, and the RabbitMQ and Redis. Plus, we have the secrets also, and the ingress. Okay, so the ingress resource is exposed via this host name, and there is a secret that is protecting the ingress via TLS certificate, and that's embedded in this secret. You can see this one, right?
Deployment configs, if you have.
Yeah. So what this backup policy, and Raghav, you can correct me if I'm wrong, but what this backup policy entails now is that all of the resources under this sockshop are now protected at a given point in time, right? And
exactly.
What we are going to do is, simulate a disaster.
Amber, can you show me if you have deployment configs as part of this too?
I mean, we can do that, but they are literally stored on my GitHub. I mean,
no, what I'm trying to say is kubectl get DC deployment configs in here. Yeah, enter. Okay, no. You don't.
No. So yeah, now what we will do is I'm gonna. So as you can see, I'm gonna delete all these resources. So basically, boom, everything under the sockshop namespace, and finally the namespace itself is kind of being deleted here, right? And it'll be a great experience seeing how this whole state of the application and the resources that provide for it get restored. So I'm going to copy this set of commands. I'm going to go back to the Ubuntu terminal and just hit. Are you okay with that, Raghav?
Yep, of course.
Okay, that gives me a lot
confidently we can recover.
You can see that everything under the sun for sockshop is gone.
Including namespace.
Including the namespace, right? And that's quite a daring act in a production system. That's a disaster, right? So we'll just wait for the sockshop namespace deletion. So as you can see that the entire namespace itself is deleted, and as a consequence, what should happen now is that I should not be able to even browse my front end of the sockshop, and it should give me the Nginx error page because this is being front-ended by an ingress controller. So you can see that it's common sense there, but I just want to kind of highlight the fact that everything is gone. Now it's time to head back to our support, the most critical support, that is the restore job from PowerProtect. I'm gonna hand over the control to Raghav, and let's invoke the the restore to see how we can successfully restore the whole act. Over to you, Raghav.
All right. So everything under the sockshop is gone, and we could see that the backup was successful yesterday. Let me check one more time. So we have 2 copies of the backup. One is scheduled, one is manual. Let's pick up the scheduled backup which is performed recently, and let's do a restore. So what we're going to do restore is a namespace. So every namespace is an asset inside the PowerProtect Data Manager. As you can see, a namespace sockshop is backed up 51 gig, and there are 6 PVCs included as part of the backup that was performed yesterday, and I'm going to restore the copy of this.
So while Raghav, you do this, I also wanted you to kind of opinionate about, although this is EKS anywhere and we are restoring to the same cluster, I do recall a lot of good options, and we'll talk about those in the restore operation in terms of restoring to alternate clusters, restoring on a cross storage class basis, because all that happens, right, in the mix for different use cases actually, right?
Yeah, we are going to walk you through all those, right? So now you got the namespace backup, and you can see crash consistent, and here are the options. Right. One, you can restore to the original cluster where you backed it up from. It could be operational restore, some sort of a corruption, or an accidental deletion that you did just now. Right. That's one option. And the other one is restore to an alternate cluster, which is useful for any cluster migrations, or you built a totally new cluster and you wanted to restore this namespace to another, or it could be a load balancing sort of namespaces from between different clusters.
So basically what you're saying is that I can restore this backup to an EKS in public cloud, or a rancher sitting next door in the cluster configuration, or an OpenShift and whatnot, right? So I mean, that's a possibility.
Right. So cross-cluster restores, it could be like on-prem or cloud, and not necessarily same platform. It could be, like you mentioned, OpenShift, and any other platform as well. Got it. Since everything is a Kubernetes underneath. Right.
And this can also mean that I can import or migrate into EKS anywhere from other platforms as well.
Exactly. So how does it work is, at the time of restoring it, you get an option. We will walk you through. You'll get an option of specifying what storage class you have on the destination cluster. Not necessarily it could be the same storage or anything, but whatever the storage classes you have it, you can utilize those and create a persistent volume on the fly while restoring it, and then restore the data and attach those PVCs and PVs to a particular namespace. So it's all taken care automatically. You don't need to scramble around. Otherwise, if you have to do this on your own with a snapshot, someone has to help you with, deployment configs. You have to deploy it, and how did you configure? Most importantly, how about secrets and all those things?
So I can't imagine that, this is 6
how it works,
and this is 6 PVCs, and creating and managing snapshots for even 6 PVCs can be a time-consuming but a very complex job. Think of 60 PVCs on a large cluster farm, which is multi-tenant cluster with namespaces differently organized. Let's say 60 or even more PVCs. I mean, it's going to be crazy out there. If disasters happen. Let's go ahead. I don't want to have too much time here, but yeah.
So we're going to restore to an original cluster. Let's look at it. Then you got a couple of options. One, restore namespace and select PVCs. You can actually exclude if you don't want to restore PVCs, etc. And if you want to include any cluster scope resources, you could include as well. Or, for example, you have the namespace already and you just want to restore only the PVCs because that's where the actual data exists, not the metadata. You could also do that, and that to select selected PVCs. Right. Let me go to the next step. So when you want to do restore to the namespace, you have a couple of options here, right? One, if the namespace exists, you can restore it, or if you want to create a totally new namespace, it could be right now what we had was sockshop as the namespace. You could say sockshop 1, and restore everything. This is particularly helpful if you want to test some sort of an application and some sort of a UAT to another cluster or to the same one. And you don't have to create it, right? And the other one is restore to an existing namespace, if at all, like whatever the cluster that you have already configured, all those namespaces are displayed here. You can pick up and restore to it.
So what I see is basically here, we have deleted the namespace, right? So literally speaking,
so we don't have that.
Shop, will it be the original or the new namespace? We'll go with the new.
It's a new namespace.
Although the name of the namespace is same, but it's gone, right, from the target.
It's gone.
Okay.
Right. It's a new namespace, but we use the same namespace which we had.
So if I hadn't deleted the namespace, only the PVCs under it and the other pods and deployment
would have gone under
namespace remains, then I can use the same one. Okay, got it. Great.
Got it. Right. Next step, and like we mentioned, it will show you all the PVCs. This is where, if you want to change your storage classes from one storage to another, it could also help you with storage migration, for example. You could really select any storage class which is available to you.
So I recall performing a similar kind of activity for a different use case though, but it helped kind of because the current storage class is based on PowerStore's CSI, the persistent layer. And think of a scenario where you don't have PowerStore, and you want to migrate to a different platform, right? Let's say that of Dell or anything, or you want to migrate to public cloud, and there EKS uses EBS CSI, or you want to migrate from public cloud to on-prem. So from EBS CSI to Dell's PowerStore CSI. So all those use cases, this is a very interesting way of looking at it.
Absolutely. I selected this option even though I'm not going to change the storage class, just to show you how it looks like. So this is where you get the storage class option. Right now you have all these, and then target storage class, if you click on it, it gives you an option with availables. As you can see, you have to do, if you have one storage class, it will show you here. You can select it and decide that as your target storage class. I'll go back and I would say don't change it, whatever was the original, and let's proceed forward. And this is the summary of what you have done.
I presume when you start this restore, there's another job that's going to be kicked in as a protection job, right? But of the type restore.
Yes,
not protect.
It is going to. Okay. It is going to, and more.
All right. So we have seen all the options, and this is the summary of what we have selected. And let me click on restore. This would execute the restore job. As you can see in the jobs, it started restore namespace. What it's going to do is it's going to spin up container proxies in particular namespace. It could be a system namespace or wherever the resource is available. And then it will try and restore the data from data domain to a PVC that is created.
So I think this will take its own time, right? In terms of depending upon the size and the size of the entire restore footprint and the complexity of the underlying resources, right? And while that happens, I think you can see that in the step logs, the queuing has already started. I think I think I saw a little more. So you can see that the restore.
Now it started. You can see that it's creating C proxy, which is a container proxy on the fly, and it started restoring session DB PVC right now, and one by one it goes through. And as we restore, we will be able to see the resources inside. By now, it would have already created sockshop namespace in the original cluster.
Got it. And roughly what, 15 minutes is what I expect
Yeah.
here. So we'll pause this recording. We'll come back, once the indicator shows success.
Absolutely.
Okay.
All right. So we're back to see whether the backup is success. Restore is success. As you can see, it is successful. Let's check what all it restored. As you can see, the metadata has been restored and then followed by individual PVCs and TVs, and then of course followed by all the metadata for it. So with this, we conclude that the restore job is successful. And now what we should have is basically a sockshop namespace with all the resources that were there in the past, including any load balancers, etc. And the application should be up and running. Amber, why don't you share your screen and show us the namespace and the status of the application? Without doing anything, let's see what happened.
Sure. No, I think also that, this has taken about 17 odd minutes. And again, as we said, right, it depends on the size of the backup and the size of the restore operations, everything. So depending upon your network connectivity, how it's kind of placed between, data domain, the target cluster and PowerProtect, the times could vary in terms of the restore operation. But our main goal here is, are we getting what we want? So we failed the entire thing. Let me share my screen.
Yeah.
First, I think from a validation standpoint, the imminent, procedure would be, you can see that we had deleted everything, right? And I'm continuing from the same terminal just to ensure that we are clear. And let's validate if we get the pods
Or the namespace.
the sockshop namespace, right? So you can see that 17 minutes it took for the restore, and these pods have been up for 13 minutes, and everything is back online. Looks good, Raghav. So I can thank you more. If I was in a production scenario and working as a owner of this cluster or this application. Now, point is that we've got the pods running. Let us also see if my PVCs are safely restored here. Okay, so clear, and it's using PowerStore, which is good. And we'll see in a moment, if these PVCs can be actually seen in PowerStore or not. But before that, let's also verify if the services are up in sockshop, so that the communication between the microservices and the databases, everything looks to be clear. Lastly, the ingress resource, which is very important, so that from a user's perspective, we don't kind of fiddle around with IP connectivity and things like that. And that's a very important part of the entire equation here. Okay, so let's see the ingress. You can see that the ingress is also safely restored. The host name is preserved. The IP address is also preserved. You can see this. And finally, the secret, which is hosting the TLS certificate, right? Now, the validation from a kubectl standpoint is clear. What we intend to do is now to validate whether or not I can access the actual application. So if you recall, we had a demo user created, and there was one order ID if you clock back in the video. Point is, the first step of validation is if I hit this URL. This is a SSS self-signed certificate, and I just showed you the secret is restored. I should not have to kind of re-accept the privacy error, because the certificate was already accepted in my browser, right? If you recall last time. So let's hit that, and we can see that I did not get another privacy error, which means that the secret and the value of that SSL certificate, that's kind of already there. It's the same, right? So although these things appear very tiny in nature, but they matter a lot from a user experience standpoint, right? I didn't have to do any changes per se, on the network side of things actually. Now let's log in and if I recall, I had put in my name as the demo user created and hopefully I remember the password, and we log in. If this login becomes successful, two things will be validated. One is the user DB and the user service microservice, right? So let's log in. You can see the login is successful. So all thumbs up there. I'm logged in as the user. Also, I can go and verify the catalog. So you can see the catalog.
And does it show your orders as well?
Yeah, we'll go there. So the catalog DB is also restored and the catalog microservice, right? So I'm just trying to kind of highlight the application workflow components as well. And finally, when I go to account, you can see that the same order has persisted during the entire backup and restore, during which we failed the namespace and then got it back. So you can see the same order ID exists. And if I view in the action, okay, so order was placed, and you can see that the order, although it's there, and the addresses and the shipping address and the invoice address, everything is there. So looks all good. And this kind of validates imagine if you had to do this manually, and that too in a firefighting situation. It's going to be a tough nut to crack. But with PowerProtect by our side, you saw how simple and easy it is. And if you keep maintaining the schedules and the routines of the backup and things like that, depending upon what RPO and RTO your business requires, you could have that amount of confidence that when things fail, you can restore them. So let's close out this scenario, and in our next scenario we will talk about a different interesting use case. So thanks, Raghav.
Right. All right, that was fantastic, and this kind of highlights seamless restore of an application. We are not talking about a data backup and all. It's like bringing up whole application.
Yeah, user
gone are those
matters.
days. Yeah, gone are those days. So yeah, backup administrator restored a system. Yeah, can you bring in application guy to bring up the application? No, this is a container world. Everything is up and running.
Yeah, one interesting thing before we close out, I think also we can highlight the fact that while we did things through a GUI on the PowerProtect, Dell has also invested a lot of effort in terms of building the right APIs for PowerProtect. So you could instrument all of this, what we did through the GUI, on a REST API basis also. Am I correct, Raghav, there?
100%. So PowerProtect Data Manager has the 100% REST API, which is very rich in nature, which means everything that you could do using GUI, you'll be able to do through REST API, which means then you have all the options to use either your favorite language, whether it could be Python or anything, to use the REST API calls, or you could use your Ansible modules to automate some of the monotonous tasks. So that's how it's powered by REST API, and you'll be able to do all the automated tasks.
Yeah, given an opportunity, we can also, extremes, but still valid, is that you can create a pipeline of sorts, where you can actually monitor your application in real time, and then basis that you can create or trigger a pipeline of restores also. So all that is possible, and the scope of today's scenario was to actually show you the functionality of that seamlessness, but a lot of possibilities there. So thank you, Raghav, again.
Sure, thank you.
Take care.
That's a great scenario. Thank you. Bye.